So today we're looking at indices and exponents and powers. All same word, mean the same thing, doesn't matter. We have had rules on indices since we were little, like year 10. We're now going to write them all down because they're going to become an important part of what we learn a little bit further on. Okay? So the first rule we learnt was that if we have a to a power times a to a power, to find the answer we add powers. Good. A m plus n. Sometimes they will not have a times sign, sometimes it will just have a dot, means the same thing. Add powers, 9. Why? Because this is a times a. Right? So there are 9 of them. Second one. A to the m over a to the n. We would minus. Good. So it's the same as divided. Sometimes they write it like this. And what we're actually doing, we're subtracting the denominator power from the numerator power. Why? Because I like 7 and 2 today. This is 1, 2, 3, 4, 5, 6, 7 over 1, 2. If we cancel, we end up with 5. Okay? So far, so good. Number 3. A to the m to the power n. We're multiplying. That says a to the m this many times. So we've got, Louis, am I boring you? No. Now you know that everybody who watches this video is going to see that. Okay, let's keep our eyes open so I don't mention names in our videos. So, because I can't ignore it, we're going to get just piled together a m n, a m times n, whatever. This could be a number, this could be a letter. For example, if we had t to the power of 7 b, then that would be t times 7 times b, which is 7b. All right? We more than likely have numbers though. So it would be like m to the power of 3 squared. That is m to the power of 3 times 2, twice m to the power of 3, m to the power of 3. So we could write it like that. Now we're just adding them. 2 of them, adding them, we end up with 6 as well. All right, so that's just the simplification of that one. The 2 extra rules I want to write down are anything to the power of 0 is gotcha, 1. It is a peculiar mathematical statement. It is designed to help us simplify. If it was 0, everything would always keep vanishing on us. So what we have to have is something that doesn't make, because we're usually multiplying, we need something that keeps things but doesn't affect them. Right? That thing when we're multiplying that keeps something but doesn't change it is 1. All right? You understand that? So we need to make sure, I always say, even an elephant to the power of 0 is 1. Right? So you'll hear me say that to you if you make a mistake. It's important. And of course, to the power of 1, which we never write, means we've got a, 1a. So we don't usually write that 1. So in the case of this one, if we had I don't want to, no, 6 to the power of 3 over 6 to the power of 3. What's the answer to that? hang on. 1, right? Anything over itself equals 1. 2 over 2 equals 1. 8 over 8 equals 1. B over B equals 1. So, if we use the rules here, 3 minus 3, so it's 6 to the power of 0. If the answer here was 0, then this wouldn't be true anymore. All right? So, to make it helpful for us, 6 to the power of 0 equals 1. All right? When we are using these rules, the likelihood is this year you'll have problems like this. Okay, and you just have to sort it out using the rules to make an answer. So this 2 is outside, it is not affected by this, but this 3 is inside, so it is affected by this. 2 times 3 to the power of 4 times a to the power of 12 times b to the power of 4. 3 to the power of 4 is 81, right? It is 3 squared, so 9 times 9, 81. So look for easy ways to work things out. Of course, you've got calculators, so you don't have to worry. Because this year you're allowed to use your calculators in algebra. A12, B4. So 162, A12, B4. All right, so you are trying to work those things out. We're going to practice that today.